Good evening students, I am Toshi Gupta and we will discuss about the resistance in this class. Now basically if you can recall, we have done the Ohm's law in the regular classes and the statement of Ohm's law says the current flowing through a conductor is directly proportional to the potential difference applied across its ends provided the physical conditions remains the same. Now the physical conditions include the length of the wire, material of the wire, area of cross section of the wire and temperature of the wire. Now this cause of the resistance is when the free electrons are going from one point to another of the conductor, they have to suffer continuously the collisions with other free electrons, positive ions. Now positive ions are the atoms from which we have got the free electrons. So they will become positively charged. And the other atoms of the conductor. Now this resistance basically if we see the factors is directly proportional to the length of the wire. Now this you can recall if we are going, say for example a number of students or your class is going through a narrow lane, then the number of collision depends how long is the lane. If we increase the length of the lane, there are more and more chances of the collisions. Similarly, if the broader lane is there, then there are less chances of collisions. So we say resistance is inversely proportional to area of cross section. Third, we say resistance increases with temperature because when we increase the temperature, then basically we are increasing their kinetic energy. And when the electrons are more energetic, then there are chances that they will move at higher velocities and they will collide more and more. And last factor is material. Material because material only decides how many free electrons will be there. अब say for example, if we take 1 meter length of the wire and say there are 1 million free electrons, which is basically approximately the case of a conductor. So when they are moving, there are more chances of errors. You can say collisions. But if we take insulator and say there are hardly 4 or 5 free electrons, then when they are moving, there are less chances of collisions. So that's why we say resistance depends upon material. So if we combine all the factors, then we get R directly proportional to L upon A. This is proportionality constant because when we say R depends upon length, that doesn't mean it is like, for example, if we increase the length, say for example we are saying resistance is 2L, resistance is 5L, resistance is 8L. Then in all the cases is depending upon L. So that's why we have to increase the proportionality constant, and this proportionality constant is called resistivity of the material. We represent it by the Greek alphabet rho. Pronunciation is RHO, rho. And now if you see resistivity, if we take L is equals to 1 meter and area of cross section as 1 meter square, then R is equals to rho. So definition of resistivity is the resistance of a wire of length 1 meter having unit area of cross section is called the resistivity of that material. Another name for resistivity is specific resistance. Now if we see the unit of SI unit of resistance, that is ohm, to give the honor to the scientist, and be symbolically represented by omega. That is the symbol of resistance. If we substitute the unit of length, area and resistance, then unit of resistivity will be ohm meter. Now basically resistivity if we see, that is a characteristic of the material and it depends upon the temperature. So while it is the useful thing for the material, so we say basically when we have to do the selection of a material for a particular application, then we have to check the resistivity of the material. For example, if we have to make the connecting wires or the connecting cord of the appliance, then we normally prefer copper and silver. Why? Because their resistivity is lower. Because it is a material constant, and whereas resistance is directly depending upon the length and area of cross section. So for 1 meter, 5 meter and 10 meter, the value will be different. Whereas for a given material, the resistivity will be the constant. Similarly, if we have to select the heating element, then we select the material whose resistivity is higher. We will discuss the terms in detail while discussing the heating effect of current. Now we are just observing because we have done the formula, so we just want to observe or check what is the effect if we stretch the wire, if we fold the wire. Now if we stretch the wire, then in that case you know volume of the wire will remain the same. So original length is L. So it means when we increase the length, then area of cross section will decrease. So we are simply applying the formula. R is rho L upon A. Say new length is L dash. Area of cross section is A dash. Say we stretch the wire so that the length increase n times of original. Then volume remains the same, means A dash L dash is equals to A into L. So we substitute the values, so we get if length increases n times, then area of cross section will decrease by a factor n, or it will become 1 upon n times of original. Now substitute the values in the new formula of resistance. R dash is rho, because rho is constant for the material, into L dash upon A dash. So on solving we get R dash is n square times R. Similarly, if we fold the wire, then in that case the length of the wire will decrease, but the thickness or area of cross section will increase. So we have new length will be 1 upon n times of original. So area will be n times of original, and on substituting the values in the formula R is rho L dash upon A dash, we get R dash is R upon n square. Now see some questions based on this. Say for example, the question is saying a wire of resistance 8 ohm is stretched to make its length 5 times of original. Find the new resistance. So we know here n value is 5. Original resistance 8 ohm. Now it depends how many marks have been allotted to the question. If the question is there, for example, say in 1 mark only, then you can directly apply the formula R dash is n square into R, or we can say 5 square into 8, and the value is 200 ohm. If they are giving it in 2 or 2.5 mark, then in that case, slightly show the steps, means you have to show some steps. You can say on stretching, new length is n times of original, so new area 1 upon n times of original, so we get R is rho L upon A. So on solving we get R dash is n square R, because there they will have the marks allotted for the steps how we are getting this formula. Similarly, we take another example, wire of resistance 4 ohm is folded so that its length becomes half of original. Then find the new resistance. So here n is 2, R is 4 ohm. Now because we are folding, so we will apply the second formula. R dash is R upon n square, and that value on solving will get 1 ohm. Again, we have to keep in mind, if the question is there for 2 or 2.5 mark, we have to show how you are getting this formula. Now one more question. Say question is saying a wire of resistance 16 ohm is cut into 4 equal parts. Find the resistance of each part. Now in this case, if you see, we are cutting the resistance in 4 parts, or the wire in 4 parts. We are not folding, we are not stretching. It means we will simply apply the logic. The resistance is directly proportional to L. Now length of each part is L upon 4. So you can say new resistance or resistance of each part will be R upon 4 or 4 ohm. Similarly, we can now solve some numerical based on R is rho L upon A. So the question is saying the resistivity of the material of a wire is given, then area of cross section and length is given, and calculate the resistivity. Take R is rho L upon A. Now resistance is given 2 ohm, length is given 1 meter, area of cross section is given 2 centimeter square. So we have to do a conversion from centimeter square to meter square. So we are having L is 1 meter, area 2 centimeter square, or 2 into 10 power minus 2 ka square meter square, or we can say 2 into 10 power minus 4 meter square. Now R is rho L upon A. So from this formula, resistivity is R into A upon L. So substitute the values in the formula and we get 4 into 10 power minus 4 ohm meter. Second question we are taking, we have to calculate the resistance of the wire, for which length is given, radius of cross section is given, and resistivity is given. Now in that case, you know the end of the wire is normally circular. So we are applying the case, area of cross section will be pi r square, pi value is 3.14 into 2 into 10 power minus 3 ka square meter square, because we have to do the conversion from millimeter to meter. So we get 3.14 into 4 into 10 power minus 6. We are not solving it here because we suggest to show all the calculation at the last step, so that if you commit any calculation mistake, then you will not lose too much marks. Say if the question is of 2 marks, you will lose only half mark for wrong calculation at the last step. But if you do the calculation mistake here, then all the values will be wrong, so they may deduct 1 mark out of 2. So now again we will apply the formula R is rho L upon A, substitute the values, and on solving we get 0.008 ohm. Now students, revise this topic thoroughly and we will discuss the verification of Ohm's law tomorrow. And at that time, have the notes PDF, or you can with you while going through the video. And your queries are awaited in the group. Thank you. Take care.